In this problem, we have a square loop with sides that are 5.46 meters long. It's made out of copper, and we got the radius of the copper wire that's making it up. And we've got the change in the magnetic field, 6.24 millitesla per second. And so we're after the current in the loop. Well, we can't get directly to the current, but we can get to the EMF real quickly, right? EMF is minus N d phi m dt. Now, the loop isn't changing at all, so that's minus N times the area, and it's just going to be dB dt. And we're given dB dt directly at 6.24 millitesla per second, right? So we know everything we need to know. N is 1. The area we get from the length, length squared, length of one side squared gives us the area. And we got dB dt already. Well, if you want to figure out the current this induces, right, you got to know use Ohm's law, right? Script E, the electromagnetic force is IR, and you're after I, right? You're after I. And so you got to calculate a couple of things. We've got the EMF. That's not a problem. What we don't have is the resistance. And to get to the resistance, you need to go back to chapter 9, right? You need to look up the resistivity rho of copper, and you've got to take the total length of copper divided by its cross-sectional area, which gives you the resistance of this square of copper. Now, the total length, of course, is 4 times the length of one side. The area, of course, is pi r squared. The cross-sectional area is pi r squared. Just have to go chapter 9, find the resistivity. Now you've got the resistance from this formula. You have the electromotive force from this formula. You're after the current. And that's it for this problem.